In this lesson, you're going to learn how to find the slope of a line given 2 points on that line. And so the directions will kind of look like this. It'll say, find the slope of each line containing the following points. So let's look at that first example. So in the first example, we have these 2 points on this line. So let's look at that line. So let's go ahead and plot those 2 points, and then we'll talk about how to find the slope of that line and we're going to use the slope formula. So we're going to look at what's called the slope formula. All right, slope formula. All right, so let's look at those 2 points on this in this coordinate plane. So we have -2, -5, and we have 1, 7. So -2, -5 is here. So there's the point -2, -5 right here. And then the other point we said was 1, 7. And so 1, 7, go to the right one, up 7. And so here's the point 1, 7. And so if I were to draw a line through those 2 points as such, like this, what I'm interested in is what is the slope of this line. So that's what I'm interested in. What is the slope of that line containing those 2 points? All right, so that's what we mean by this problem. Okay, now let's look at this situation first. So we're going to first of all come up with the slope formula. So let's talk about the slope formula. So let's look at this situation. So I have this coordinate plane. So here's the x-axis, here's the y-axis. All right, and let's suppose I have these 2 points here, this point and this point. And let's call this point here, the x-coordinate here is x sub 1, and then the y-coordinate is y sub 1. So the coordinates here are x1, comma, y1. And for the second point, so in the second point, let's call this x-coordinate here, x sub 2, and this y-coordinate, y sub 2. So the coordinates of the second point, we're going to label x2, comma, y2. And what I'm interested in is how to determine, how to come up with that formula for the slope of that line. So that's what I'm interested in determining. Okay? So the slope of a line, we're going to define the slope. I'm going to use the letter m, lowercase m for slope. So you'll see this, instead of writing the word slope, we'll just indicate the letter m. So slope is defined as rise divided by run. Okay? Rise divided by run. So if I were to draw a right triangle, an imaginary right triangle like this, all right? And this right here would be considered the rise, so that's your rise right here. And then this here would be considered the run, okay? So that horizontal distance here is the run, and that vertical distance is the rise. So when I go from this point to that point, I'm going to go to the right and then up, okay? So to the right and then up. Now you could have gone this as well. You could have gone up and then right, but it doesn't matter. All right, you'll still end up with the same slope. The value of the slope will be the same. Okay, now here's something important. So I'm going to go ahead and label this point here. So where those 2 dotted lines meet, the coordinates of this point right here is x1 and then y1. So go to the right, x2. Go to the right x2 and then go up y1. So this is x2, comma, y1. And so when I'm trying to find this vertical distance, when you're trying to find this vertical distance here, all you're doing is subtracting the y coordinates. So the rise here will be y2 minus y1, okay? And then over here, when finding the horizontal distance, we're going to subtract the x coordinates. So the x coordinate here is x2, the x coordinate here is x1. So that's going to be x2 minus x1. All right? And so when I rewrite this here, so the slope, which we said is rise over run, right, will be, and then my rise is denoted as y2 minus y1. divided by, now this is important, since I put y2 first, since I put y sub 2 first, since I put that second coordinate here, the y2 first, then I must put x2 first in the denominator. So you must say x sub 2 minus x sub 1. Okay? So if this says y2, then the first term here better be x2. And so that's your slope. That's the slope formula. So basically all you're doing to find the slope of a line given 2 points is you're going to say rise over run. Always think rise over run. And when you think rise, think the y-axis. When you think run, think the x-axis. So y is in the numerator, x is in the denominator. So you're going to subtract, notice the subtraction, you're going to subtract the y coordinates from each other, and then you're going to subtract the x coordinates from each other. But if you put y2 first, then you better put x2 first in the denominator. Now you could have also said this, I'm just going to say this because some of you are going to do this. You're going to say y1 minus y2, and that's fine. You can say y1 minus y2. But in the denominator, you must say x1 minus x2. All right, so you must keep those subscripts the same. You must keep those subscripts the same. All right, so remember, subtraction, the order in which you subtract does matter. Subtraction is not commutative. So y2 minus y1 is not the same as y1 minus y2. All right, so they're opposites. The same thing for the denominators. Those are opposites. But if you keep the subscripts aligned, the value of that fraction will be the same. Okay, so the slope will be the same. All right, so that's your slope formula. Now, when using a slope formula, I'm going to just go ahead and use the one that begins with y2 and the denominator x2. Okay? All right, so now that we know where the slope comes from, remember slope is kind of like the steepness of a line, but remember it's rise over run. So think rise over run. Rise is the y, think of the y-axis. Run, think of the x-axis. That's why you see y is in the numerator, x is in the denominator, and it's to change. So sometimes you'll see this. So you'll see slope equals rise over run. So you'll say change in y divided by change in x. So by change, we kind of mean the difference. So the difference in the y coordinates divided by the difference in the x coordinates. Okay? All right, so let's look at this first one. So it's very simple. It's very simple to find the slope of a line given 2 points. Now here's what I suggest. I suggest that you label these coordinates. So remember, the slope formula is y2 minus y1 divided by x2 minus x1. All right, so y2, x2, y1, x1. So let's label this. So let's call this the first point. So this is going to be x sub 1, y sub 1. So the x and y coordinates of my first point. So that's why you see the subscript 1. And then here we'll say x2, y2. And then it's just a matter of you plugging it into your formula. And so y2 is 7. So I get 7, subtract the other y coordinate, which is a negative 5, just like this. 7 subtract negative 5. Divided by x2. Since I started with 7, you got to start with 1, okay? You must start with that same point. So the x coordinate's 1, so we're going to subtract the x coordinate here, which is a negative 2. All right? And so I get 7 subtract a negative 1 means the same thing as 7 subtract a negative 5 means the same thing as 7 plus 5. 1 subtract a negative 2 means the same thing as 1 plus 2. So 7 plus 5 is 12. 1 plus 2 is 3. 12 divided by 3 is 4. So the slope is 4. Okay? So your slope is 4. Now I just want to say something. Remember we said you could have said y1 minus y2 divided by x1 minus x2. I just want to show you are going to get the same slope, the slope of 4. Watch. So if we start with y1 instead, see that negative 5? Slope will be negative 5, subtract, so this y coordinate, subtract this y coordinate, 7, divided by, since I started with negative 5, I must start with negative 2, subtract 1, and then watch. A negative 5 and a negative 7 is a negative 12. Negative 2 and a negative 1 is a negative 3. So when you change them, remember we said earlier the 12, 3, and these should be the opposites. But negative 12 divided by negative 3 is still a positive 4, so you get the same thing. All right? So that's your slope. So the slope is 4. All right? Slope is 4. Now notice this slope is positive, so I want to make a connection now because it's going to be important. You always read a graph from left to right. So as I go from left to right, I want you to notice I'm tracing over the graph. I'm going from left to right, I'm going up. You see that? I'm going up. So I'm increasing. I'm rising. So whenever the slope is positive, since the slope is positive, the line rises. Okay, so the line rises, the line increases. Just put in parentheses, increases. All right, so the line rises. See, it's rising. And when I say it's increasing, what I actually mean by that, and you're going to see later, is that your y coordinates are increasing. They're getting larger and larger and larger. So as you go from left to right, your y coordinates are increasing. So we just say your line rises. Okay? So that's how you find a slope, is just using this formula and substituting the coordinates into this formula. And you found the slope. So the slope is 4. Okay? So there's the work. And then there's the answer. So the slope is 4. Make sure if it says show work, you just don't go from here to the answer. You got to show something. Okay? All right, so that's number 1. Let's look at number 2. So it's very simple process. So let's say we had 3, negative 1, and negative 2, 5. Let's say we had that. All right, so I want to find the slope of the line containing those points. That's what I'm interested in doing. All right, so let's look at this. So I have, so it's a good idea to label those points. Some students do. All right, so say x1, then this has to be y1. So if this is that sub 1 means the first point. So if this is the x coordinate of that first point, then this is going to be the y coordinate of the first point. And so this is the second, so you can say x2, y2. And so here's the formula. You're going to say y2 minus y1 divided by x2 minus x1. Y's divided by x's. The change in y's divided by the change in x's. If you say y2 first, you better say x2 first. All right? And so y2 is 5. Subtract x1, which is 3, right? I'm sorry, y1, which is negative 1, excuse me. 5 subtract negative 1, so y2 minus y1. And then you subtract the x coordinates, so negative 2 subtract 3, right? Okay, so look, 5 subtract a negative 1 means the same thing as saying 5 plus 1. So, because remember, whenever 5 subtract negative 1, whenever you're subtracting, you can always change subtraction to addition. So that becomes 5 plus the opposite of negative 1, which is a positive 1. So that becomes 6, right? So 5 plus 1. The denominator, negative 2 plus a negative 3, is a negative, what's that, negative 5? So I get 6 divided by negative 5, which is a negative 6/5. You can write it like that. So there's your slope. So your slope is negative 6/5. Okay? And so I just want to show you, if you were to plot those 2 points, I want to show you something. So 3, negative 1, so there's your answer. You're done. You're done with this problem. So there's your work, there's your answer. But I want to show you something in terms of the graph. So in terms of the graph, we have 3, negative 1. So to the right 3, down 1. So here's 3, negative 1 right here. And then negative 2, 5. So negative 2, 5 is here in the second quadrant. So there's negative 2, 5. And then there's 3, negative 1. If you graph the line containing those points, what we just did was we just found the slope of that line. We found the slope of that line. We also found that the slope of the line is negative. So notice, in this case, the slope is positive, right? And as I go from left to right, that line is rising. So hence, slope is positive. Here, though, when I go from left to right, the slope is falling. You see how my pencil point is going down? Slope is falling. So hence, the slope is negative. Slope is negative. So since the slope is negative, the line falls. Okay, or we can say decreases. And when I say decreases, this is really what I mean. As I go from left to right, those y-coordinates of those points, those y-coordinates are decreasing. They're getting smaller and smaller and smaller. So you see this y-coordinate's 5 right here. What's this y-coordinate right here? -1, right? So -1 is smaller than 5, so it's getting smaller. That's what I mean by decreasing. So it's falling. When we say it's falling, it actually means those y-coordinates are decreasing. So two things. If the slope is positive, the line rises. If the slope is negative, the line falls. You also know now how to find the slope given the slope formula, right? All right, let's do another one real quick. So here's number 3. So let's do number 3. So in number 3, let's suppose we had this problem. Number 3. We have 0, -4, and -7, -3. Let's say we had that, okay? All right, so let's find the slope. So to find the slope, we're going to label this as x sub 1, y sub 1. So my x coordinate of my first point 0, the y coordinate of my first point is -4. And then here we'll say x2, y2. And then I'm just going to plug into the formula. So remember the formula is y sub 2 minus y sub 1. The y's are in the numerator. And then x sub 2 minus x sub 1. The x's are in the denominator. So remember change in y divided by change in x. Rise divided by run. Change in y divided by change in x. Since the operation is subtraction, the order matters. Order matters. If you start with y2, you have to start with x2. All right, so let's go ahead and substitute now. So y2 is -3. Subtract y1, which is -4, divided by x2 is -7. Subtract x1, which is 0. The numerator, -3 minus a -4 is -3 plus 4, right? It's -7 subtract 0 is -7. -3 plus 4 is 1. And here we get -7. So the slope is -1.7. Right? Slope is -1.7. So if I were to graph this line, would the line rise or would the line fall? The line would fall, right? Because the slope is negative. Since the slope is negative, the line falls. All right, so there's your answer. The slope is -1.7. All right, so let's look at number 4. So number 4, let's look at this one. So I want you to think about what we're about to do. So number 4, we have, and by the way, if you can reduce, make sure you reduce. So let's say number 4, we had 8, 6, and -1, 5. Let's just say we had, let's make that 8 right here. I'm sorry, -1, 8. That's an 8. So x1, y1, x2, y2. So you're trying to find the slope of the line that contains those 2 points. So the slope will be y2 minus y1 divided by x2 minus x1. So y sub 2 is 8. So I'm going to say 8 subtract 6, right? Divided by -1 subtract 8. So 8 subtract 6 is 2. -1 and a -8 is a -9. I cannot reduce, so the answer is -2/9. So there's the slope. Again, the slope is negative. The line falls. Number 5, we have -6, 4, and let's say 8, 4. Okay, so -6, 4, and 8, 4. All right, so let's find the slope of that line. So let's find the slope first, and then I'm going to go ahead and graph this just to show you something. All right, so let's call this x sub 1, y sub 1, and this is x sub 2, y sub 2. So the slope, remember, is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, right? And so y sub 2 is 4, so I get 4 subtract y sub 1 is also 4. So I want you to notice those y coordinates are identical, right? They're the exact same value. They're the exact same number. So 4 subtract 4 divided by x sub 2 is 8, subtract a -6. Well, 4 subtract 4 is 0. 8 subtract a negative 6 means 8 plus 6, and 8 plus 6 is 14. 0, you got to simplify. 0 divided by 14 is 0. So the slope is 0. All right, slope is 0. So this line has slope 0. So what does that mean for it to have slope 0? Because the point is this. Here the slope is 4, right? And when we saw that the slope was positive, we saw that the line rose. So as you go from left to right, the line rises. Over here, we saw the slope is negative. Well, when we saw the slope is negative, which is this line here, the line fell. As you go from left to right, your line is falling. Your line decreases. But in this problem, number 5, that's not a positive number, and that's not a negative number. That is 0. That is 0. The slope is 0. So what does that mean? What does the graph look like? So let's look at that graph real quick. So let's go ahead and plot those 2 points, and let's see what that graph looks like. So we have the point negative 6, 4. So negative 6, 4 is here, right? Here's negative 6, 4. And so we go to the left 6 and then up 4. And then the other point we said was 8, 4, right? So 8, 4, we go to the right 8 and then up 4. I want you to notice this. So here's 8, 4. When I draw the line containing those points, which is this right here, what kind of line is this? As I go from left to right, the line does not rise, the line does not fall. What kind of line is this? Notice the y-coordinates are the same. Every point, the y-coordinate is 4. So what kind of line is this? It's a horizontal line. A horizontal line. So here's what I want you to remember and understand. So note, since the slope of the line is 0. Okay, since the slope of the line is 0, the line is horizontal. The line is horizontal. So whenever you have a horizontal line, all horizontal lines will have slope 0. It makes sense because notice when I go from this point to this point, I run. There's a run, but there's no rise. See, there's no rise. So over here, watch. Let me get to that previous graph. Look, there was a run and there was a rise, right? There was a run and a rise. Here, there was a run and a rise. Of course, I went down, so that's why it's negative. But there was a run and a rise. Here, there's a run, but I'm not going up or down. I stay there. I stay on that point where my y value is the same as this one. So all horizontal lines will have slope 0 because the rise, when you subtract the y's from each other, that's your rise. The coordinates are the same. 4 subtract 4 is 0. Whatever, if you're looking at this horizontal line, let me do that here. If you're looking at this horizontal line right here, so let's say we have this point here, which is negative 5, negative 3. And let's say we have this point here, which is 4, negative 3. Notice my y coordinates are the same. So when I find the slope and I subtract the y coordinates from each other, negative 3 subtract negative 3, divided by 4 subtract negative 5. Notice my numerator, negative 3 plus 3. My denominator is 4 plus 5. Negative 3 plus 3 is 0. And the point is that when you look at all horizontal lines, that change in y coordinates, change in y, or that rise will always be 0. And then the denominator will be some value. Okay? All right. So, since the slope is 0, your line is horizontal. All right, let's do one more. And what do you think that one's going to be? What do you think we're going to end up with the next one? If this line was horizontal, then let's do one where the line is vertical, right? So let's look at that one. So this is number 6. It's a very simple process using a formula, right? So using a formula, in all these problems, we use that formula to find the slope. Same formula. Okay, number 6, let's say we have, 4, 5, and this time 4, -2. Okay? Notice this time the x coordinates are the same. Here, the y coordinates were exactly the same, right? Here, the x coordinates are the same. So let's see what happens there. So let's call this x1, y1, x2, y2. And so the formula for slope is y2 minus y1 divided by x2 minus x1. Change in y divided by change in x. Rise divided by run. Okay, so my y2 here is -2. So I have -2 subtract 5 divided by 4 subtract 4, right? So -2 and a -5 is a -7. 4 subtract 4 is 0. All right, now you got to remember something. You can never divide by 0. So that's undefined. Don't say 0. The only time you get 0 is when the numerator is 0 and the denominator is some other number other than 0. So 0 divided by 14, 0. -7 divided by 0 is undefined, right? So you can say one of two things. You can say this. Listen carefully. You can say slope equals undefined, so the slope is undefined. Or you can say there is no slope. So this line has no slope. This line has no slope. Don't confuse the phrase no slope with slope 0. This line has a slope. It's 0. It's hard, so that's why that line's horizontal. This line has no slope. So when I graph it, it's going to be vertical. I want to show you that. So let's look at that. So here we're going to graph this line. So let me get some grid paper. Okay, so we have 4, 5, and 4, -2. So 4, 5, right here. That's in the first quadrant, and then 4, -2 is in the fourth quadrant. 4, -2, and when I graph the line, notice that I will get a vertical line. And we saw that the slope is undefined, right? So the slope is undefined, or we can say no slope. There's no slope, so that means the same thing. So the slope of a vertical line, there is no slope, or we can say undefined. So we're going to say this. Since the slope is undefined, the line is vertical. The line is vertical. So all vertical lines, so if I draw this vertical line right here, all vertical lines have undefined slope. All vertical lines have undefined slope. Okay? So since the slope is undefined, the line is vertical. And that's it. So that was just using the slope formula. It's a very simple process to use a slope formula. So you just substitute those values into the formula. But make sure you understand what slope is. And so that's why we talked about how did this slope come from? How did this formula come from at the beginning? All right. And then we also talked about if the slope is positive, the line rises. If the slope is negative, the line falls. We also saw that if the slope is 0, the line's horizontal. And then finally we saw that if a line has no slope, or we can say undefined, that's where the denominator is 0, then it's going to be a vertical line. All right, so that is the end of this lesson.